Good afternoon, my dear students. So, in these sessions, we are going to learn a third problem on the spring. Design a spring for a balance to measure 0 to 1000 Newton over a scale of 80 mm. So, this means that on the spring, we are applying the load in the range of 0 to 1000 Newton. So it causes the deflection length we got as 80 mm. The spring is to enclose in a casing of 25 mm diameter. The approximate number of turns of a spring is given as 30. The modulus of rigidity is 85 kN per mm square. Also calculate the maximum shear stress induced. Okay. First of all, I will write the given data. Okay. So here in this case the load, how much is given here? The load is given as 1000 Newton over a scale length 80 mm. So this means that it is a deflection due to applied of compressive load. How much deflection is there? 80 mm. The spring is to enclose in a casing of 25 mm diameter. Okay. The approximate number of turns, here approximate number of turns is given as 30 and the modulus of rigidity is given as 85 kN per mm square. So we can represent here modulus of rigidity. It is represented by G equal to 85 kN per mm square. So in this case we need to find out the maximum shear stress induced. We need to find out. First of all, we need to design of spring. Okay. So I'm representing here so this is fixed one. Let us see. This is the axis of a spring. Okay. Then, so let us think about it. This spring is rigidly fixed over here. Is it right? Like this. This spring is rigidly fixed over here, and we are applying the compressive force on the axis of the spring. Is it right? So this one, before we are applying the load, so we can say as this one is free length. What we can say here? Free length. And this one, what we can say here? Diameter of the wire. And this one we can say as pitch. Pitch nothing but the difference between the two spring. Okay, so we can say as pitch. And here the center line we can say as mean diameter. Okay, this inside one we can say as di, inside diameter of the spring. Outer one we can say as outside diameter of the spring. Is it right? It is represented by capital DO or small do. The meaning is should be remaining same. So let us think about it. If we applied the load in the range of 0 to 1000 Newton, so the maximum load is 1000 Newton we are applying. Is it right? So if you applied the load of 1000 Newton, due to what happened here, compressive force is acting on the spring. If the compressive force is acting on the spring, this spring will be compact in the shape. Is it right? That decrease the length of the spring due to apply of compressive force on it. Is it right? So the same thing what I am doing here, I am taking the figure like this. This is fixed one. Okay, the same I am taking from here. This is springs. Okay, so if you apply the compressive force on it, due to what happened here, it causes the deflections is occurring in the spring. So it is represented by delta. So it is before loading, the wave figure should look like this. If you apply the compressive force on it, it causes spring will be compact in shape. It should be decreased that much. How much decrease will be there? 80 mm decrease due to applied of 1000 Newton on the free length of the springs. Is it right? So it is W. So we can say that, so what we can say as D, so D nothing but diameter, or we can say as mean diameter of the spring coil we can say, and small d what we can say here, this is small d we can say as diameter of the spring wire we can say, as well as if the spring is to enclose in a casing, if the spring is enclosed in a casing of 25 mm diameter, so here the diameter how much is given, the enclosed in a casing is given as 25 mm diameter is given. So the outside diameter of the spring coil is should be lesser than 25 mm. The outside diameter of the spring should be lesser than 25 mm. Is it right? So let consider, so capital D what we can say here, mean diameter. Is it right? Mean diameter of the spring we can say, mean diameter of the spring coil. Okay dear. And so small d what we can say, diameter of the spring wire. What we can say here, diameter of the spring wire we can say. If you want to find out the spring index, you can easily find out. So spring index, if you want to find out, so which formula you are using here, C is equal to, spring index is nothing but mean diameter of the coil by diameter of the wire. Is it right? So in the question is, the condition is given as the spring is to enclose in a casing of 25 mm diameter. Okay, so we know very well the outside diameter of the spring coil should be lesser than 25 mm. So the condition, what the condition is given, the condition is given here, the spring is to enclose in a casing of 25 mm diameter. spring is to be enclosed in a casing of 25 mm diameter. So we know very well the outside diameter, this outside diameter of the spring coil should be lesser than 25 mm. Okay here, so what I'm telling here, outside diameter, so this one we can say as outside diameter of the spring coil. So outside diameter, what we have to represent, DO equal to outside diameter, mean this is the diameter of the wire plus mean diameter should be less than 25 mm. Is it right now here? So it is visible. Okay. So we know that the deflection of the spring, okay, we know that deflection of the spring delta. So we know the formula is delta equal to, okay, it's visible, delta equal to 8W C cube into N by G into D. So what is the formula of deflection of the spring? The deflection of the spring, the formula we have 8 into load into spring index cube into number of the turns by modulus of rigidity into diameter of the wire or diameter of the spring. So delta, so due to the apply of compressive force on it, the deflections we got as 80 mm. So I am representing here deflection is 80. 80 is as it is. How much load we applied on the spring here? We applied the load of 1000 Newton into 1000 into the spring index. We don't know, is it right? C cube as it is. So number of turns of a coils, how much are there? It is given 30 by modulus of rigidity. It is given in the question 85 into 10 power of 3 D as it is. Okay dear, then if you cross multiply, then you will get the value of C cube by D. So we need to cross multiply this term. So like this, 80 as it is equal to, if you multiply, otherwise one more options will be there, you can do like this also, 8 into 1000 into 30 by 85 into 10 power of 3. Is it right? Then you will get the same value like this. Okay, so we can say that it is the value of 240 C cube as it is by, this is 85 as it is. Okay, so like this, these thousands will cancel. 8 into 30 should be 240 into C cube, 85 into, this is small d value. Other, you can easily cross multiply here, 80 into 85 by 240 equal to C cube by D. Otherwise you can easily direct cross multiply, then directly you will get the answer. Okay dear, C cube by D. So if you calculate 80 into 85 by 240, then you will get the answer is 28.3. Is it right? So after that, if you multiply this D, then you will get the value of spring index. Is it right? So in this case, what I'm doing here, I'm assuming here. Why? I'm assuming here in this case. So why I'm assuming, I will tell you later. Okay dear. So why I'm assuming, that is the most important, because our diameter, outer diameter should be lesser than 25 mm. For that reasons I'm not taking the 5. Instead of, you can take 2, 3. Is it right? You can check it. But we know very well, if you take the 4 mm, then you will get the answer less than 25 mm of outside diameter. Is it right? So let assume D equal to 4. Okay dear. So I'm assuming that the diameter of the coil I'm assuming as 4 mm. Then after that, you need to cross multiply this term like this: C cube into 28.3 into small d. So 28.3, d value I'm assuming as 4. So after that, if you multiply 28.3 into 4, then you will get the answer of 113.2. So if you remove the cube, it make the power as 1 by 3. So 1 by 3 nothing but 0.333. So if you calculate, then you will get the answer is 4.84. C value, C nothing but spring index value, how much we are getting here? 4.84. So after that, actually our intention is we want to find out the outer diameter of the coil. We need to find out. If you want to find out the outer diameter of the spring coil, okay, it's visible. Okay, it is visible. Outer diameter of the spring coil. So we have the formula is D equal to spring index into diameter of the coil. Okay, or we can say as diameter of the springs. So here C value, how much we got here? 4.84. Spring index value is 4.84 multiplied by D. D I am assuming as 4 mm. If you multiply this term, then you will get the answer is 19.36 mm. So this indicate that is the outer diameter of the spring coil. Okay, so after that, we know very well the outer diameter of the spring coil. So we know that the outer diameter of the spring coil, what is the formula is there? D plus small d. So outer diameter of the spring coil, diameter of the spring coil. So this D what they indicate? This D is indicate that is a value of mean diameter. Don't be confused. Okay dear, don't be confused. So this is value of mean diameter is C into D. After that, outer diameter, if you want to find out, DO is equal to mean diameter plus diameter of the wire. So D, how much we got here? 19 point, it's visible, okay, 19.36 plus 4. If you add this value, then you will get the value of 26.36 mm. So this means that the outer diameter of the spring coil is less than casing diameter of 25 mm. So it is less or not dear? It is less than 25 mm. Is it right? So whatever dimension, whatever the D equal to 4 we assume, it is correct only. Is it right? So here I am getting the value is how much? Outer diameter is 23.36 mm. Is 36 mm is less than how much, dear? Is less than casing diameter of is less than 25 mm. 25 mm of casing diameter. Is it right? Assume dimension. How much we assumed here? 4 we assume. Is it right? Assume dimension D equal to 4 mm is correct. Okay, dear. 4 mm is correct. Okay. After that, in the second case, what we need to find out? Our intention is we need to find out the maximum shear stress induced. We need to find out in this case. So if you want to find out the maximum shear stress induced, then we have to use the formula of Wall's stress factor formula. Here, maximum shear stress induced. Maximum shear stress induced. So we know the formula of Wall's stress factor. We know that Wall's stress factor formula. So what is the formula is given here? So we know the formula is K equal to 4 C nothing but spring index minus of 1 by 4 C minus of 4 plus 0.615 by C. So we need to refer the table. Okay, so we need to refer the page number 139 or 11.2b 139, then you will get the formula of Wall stress factor. So you have to so the Wall stress factor K is equal to 4C minus of 1 by 4C minus of 4 plus 0.615 by C. So please refer the Mahadevan design data handbook. Refer the page number 139 11.2b, then you will get the formula of Wall's stress factor. Okay, and then 4 is as it is. C nothing but spring index is how much we got here? 4.84 minus of 1 by 4 into 4.84 minus of 4 plus 0.615 by spring index is 4.84. Then if you calculate with the help of calci, then you will get the answer of 1.322. That is the value of K. Okay, dear. After that, we need to find out the maximum shear stress induced. Okay, what we need to find out here? We need to find out the maximum shear stress induced formula. Maximum shear stress induced. So we know the formula is tau is equal to K into 8W into C by pi d square. So what is the formula is there? Tau is equal to Wall's stress factor into 8 W nothing but how much load is applied on the spring into C nothing but spring index by pi into D nothing but diameter of the wire. So okay, so K how much we got here? 1.322 into 8. W load how much is there? 1000. C is how much is there? 4.84 divided by pi. D square value is 4, we are assumed. Is it right? So if you calculate with the help of calci, then you will get the answer is 1018.2 Newton per mm square. So we know very well 1 Newton per mm square should be equal to how much here? 1 megapascal we can say. Is it right? So tau equal to, we can represent 1018.2 megapascal. Okay dear, I hope so no one is having the doubt regarding this problem. If you have the doubt regarding, please write down in the comment box, and please like, share and subscribe my video. Thank you.